Trig identities and compound angles. We remember two formulas. Sine x plus y will be sine x cosine y plus cosine x sine y. We have cosine of x plus y. Trigonometric identities and compound angles. We know two formulas. Sine x plus y for the compound angles, sine x cosine y plus cosine x sine y. When I have cosine x plus y, it will be cosine x cosine y minus sine x sine y. Now we need to simplify this. Here you have cosine of these, so you can apply this formula here. So you get cosine x cosine pi by 6 minus sine x sine pi by 6. So we are done for the first one. Plus this one we can compare with this, but we will replace y by negative pi by 3. Or you can remember, when you have a negative here, you just put a negative on this. So let's use that one, negative here and here. So we will get sine x cosine pi by 3 minus cosine x sine pi by 3. And you remember from the complementary angles that sine pi by 6 and cosine pi by 3, they are same. We know that sine pi by 6 is same as cosine pi by 3, because pi by 6 and pi by 3 are complementary angles. Pi by 6 is 30 degree and pi by 3 is 60 degree. 60 plus 30 is 90. So they are complementary. So then this term, same. Now here, sorry, I forgot here sine. So you have sine x sine pi by 6 minus sine. So these two will cancel out. Now we know sine pi by 3, which is 60 degree, right? And then cosine pi by 6 is 30 degree. So we know cosine pi by 6 is actually radical 3 over 2, and we have a cosine x in here. On the other side, we have sine pi by 3 is radical 3 over 2, and we have a cosine x. So this is coming out as 0. Now we need to find the value of cosine 3 pi by 7, cosine 2 pi by 21, plus sine 3 pi by 7, sine 2 pi by 21. Now you can see cosine, cosine, sine, sine. So this goes with this formula. If I have a plus sign here, then this will be minus sign here. So this one, basically you can say that this is x and this is your y. So then this whole expression is cosine 3 pi by 7, which is x, minus y will be 2 pi by 21. Now make the common denominator. Oh, I have a 7 here. So then you get cosine, your common denominator is 21. So then you get a 9 pi minus 2 pi, which is cosine 7 pi over 21, same as cosine pi by 3. So pi by 3 is 60 degree, and we know cosine 60 is 1/2. So this answer is 1 over 2. So first of all, we know sine of negative will give me just negative sine pi by 12. Now we need to find the value of sine pi by 2 using the reference angles. For simplicity, I show you that pi over 12 can be written as pi over 3 times 4, and this is same as pi by 3 minus pi by 4. This is very easy, you can verify. Now we'll be working on sine pi by 3 minus pi by 4. So this one is simply sine pi by 3 cosine pi by 4. I'm just using same formula here, only I have a negative here and here because I have negative. And then cosine pi by 3 sine pi by 4. And remember, pi by 3 is 60 degree, pi by 4 is 45 degree. And from the unit circle, we know sine pi by 3, which is sine 60 degree, that is radical 3 over 2, and cosine pi by 4 is radical 2 over 2, minus this one is cosine 60, which is 1/2, and this one is radical 2 over 2. So we are getting radical 6, you can say, over 4 minus radical 2 over 4. So you can write like 4 and then radical 6 minus radical 2. If you want, you can further write, so this radical 6, if I just keep it like radical 3 times radical 2, then you can say that I factor out radical 2, and then I will have radical 3 minus 1. So this is my simplified version of the result. So I'm writing again. We're done. And then finally, if you put the result in here, so then you get a negative in front, then you have radical 2, radical 3 minus 1 divided by 4. So this is our final answer for this problem. We take another similar example. First, you see 19 over 12 can be written as 1 plus 7 over 12. So then this one can be written as sine pi plus 7 pi over 12. Now we can see here pi plus, we are going in the third quadrant. In the third quadrant, sine is negative. So this one is coming out as negative sine 7 pi over 12. Now 7 pi over 12 can be written as pi by 3 plus pi by 4. It's a lot of typical examples. So we are actually converting all this to the reference angle. Pi by 3 and pi by 4, these are reference angles. So then let us start with sine 7 pi over 12, which is sine pi by 3 plus pi by 4. Now we can use our formula here. That will give me sine pi by 3 cosine pi by 4 plus cosine pi by 3 sine pi by 4. And remember, pi by 3 is 60 degree. So sine 60 is radical 3 over 2. Cosine pi by 4 is radical 2 over 2. Cosine pi by 3 is 1/2. Sine pi by 4 is radical 2 over 2. So then, as before, like the other example we had, you can put a 4 here, and you can factor out radical 2. So we end up with radical 3 plus 1. So when you put it back in the problem, you just have a negative in front, and then you have radical 2, then radical 3 plus 1 over 4. This is our final answer. Next, we'll produce another formula for tangent x plus y equals what? So it is, with this, we can go sine x plus y over cosine x plus y, and then just write the expansions. So sine x plus y is sine x cosine y plus cosine x sine y divided by cosine x cosine y minus sine x sine y. So our tangent in terms of sine cosine is this. If we want to go back in terms of tangent, we can easily do it. So now we want to divide each term by cosine x cosine y. So if I divide this by cosine x cosine y will cancel out. Sine x over cosine x will be tangent x. And if I divide this one by cosine x cosine y, so cosine x will cancel out, sine over cosine will be tangent y. And then if you divide this by cosine x cosine y, you get 1 minus sine x over cosine x will give me tangent x, and then sine y divided by cosine y will give me tangent y. So we have got a formula for tangent x plus y, which is tangent x plus tangent y, and 1 minus tangent x tangent y. Now if you replace this by a negative, you get a negative here and a positive here. Okay, we'll take one example. So we got our two new formulas. Tangent x plus y is tangent x plus tangent y, 1 minus tangent x tangent y. If I have a negative, if I replace y by negative y, so you know tangent is odd function, so this will produce a negative sign in front. This also will produce a negative sign, that becomes positive here. So you can remember tan x plus y will be tan x plus tan y, tan x minus y will be tan x minus tan y. If you have a minus here, then plus here. If you have a plus here, then minus here. So this way it is easy to remember. Now we take one example. So in this example, we want to find the exact value of tangent 74 degree minus tangent 14 degree over 1 plus tangent 74 tangent 14. So if you compare with this formula, you can see you have a minus here and a minus here. So then x is actually 74 and y is 14. So you can use this form here. So this one is same as tangent 74 degree minus 14 degree, which is tangent 60 degree. If you don't remember the value of tangent 60, you can write this one as sine 60 degree over cosine 60 degree. So you know sine 60 degree is radical 3 over 2 and cosine 60 is 1/2. So then this is basically radical 3. We are done.